Hello dear students, welcome back to Jatin's Academy. So today in this class we are going to start with the third chapter of 8th ICSE Physics, that is force and pressure. So today in this class we are going to discuss about what is force, then we will discuss examples of force as push and pull, then we will discuss about effects of force, then we are having turning effect of force, next we are having numerical problems related to turning effect of force, then we are having pressure, then we will discuss about examples of pressure, and then afterwards liquid and atmospheric pressure, then we are having numerical problems related to pressure, then consequences of liquid pressure, then at last we will discuss about effects of atmospheric pressure. So now let us start. So first topic we are having, what is a force? So as the chapter name suggests, force, so we should know first what is a force. So what is a force? Here we are having definition: a push or pull to an object which change or tends to change the motion of an object. Means whenever we are pushing or we are pulling to any object, that push or pull to any object is nothing but we are applying a force. And due to that push or due to that pull, when the object changes its motion or changes its direction, that is nothing but it is a force. So push or pull means what? Push means whenever we are applying force and the object is moving away from you. When object is moving away from you, that is a push. And what do you mean by pull? Pull means whenever you are applying force and object is coming towards you, that is a pull. Okay, this is a push and pull. So see with example. So here we are applying force to the ball and ball is moving its or changing its motion. So next we are having like this. Here we are pushing the ball and here we are pulling the cart. Here is a pushing, here is a pulling. Okay, so push or pull to an object which change or tends to change the motion of an object is called force. So next we are having examples of force. As I already told that force is a push or pull to an object. We will see the examples where force acts as a push and in which examples force acts as a pull. So first example we are having, to enter inside a room, we open the door by pushing it. When you want to enter inside the room, we always push the door in order to move inside the door. So that this is the example of force as a push. So next we are having examples of force as a push. Second example, if car is not starting by its own engine, so we have to push the car, means this man is pushing the car in order to move it forward, or here you can see this boy is pushing the cart in order to move the cart. So this is an example where force is acting as a push. Okay. Next example we are having force as a push in a game of carom. When we are playing carom board, in that we are always pushing the striker. Here a man is applying force or pushing the striker in order to move the striker or coins. Okay, so here this push is nothing but a force applied by a person. Next we are having examples of force as a pull. In some cases we are pushing something, in some cases we are pulling something in order to show our force. So first example we are having as force as a pull. So here we are having to come out from room, we close the door by pulling it. When you come out from the room, we have to close the door. So how you will close the door? By pulling it. Pulling it means by taking the door towards yourself. So that pulling is nothing but a force applied on a door and door closes by our force. So next example we are having, a rickshaw puller pulls his rickshaw. So rickshaw puller is also pulling his rickshaw, means he is applying his force in order to move the rickshaw. Next we are having effects of force. So as we know, force is a push or pull to an object which change or tends to change the motion, direction, means due to applying force, many effects have seen in the object. So which effects we are going to see in the object, that effects one by one we are going to study. So first effect we are having, a force may start motion in an object which is at rest. For example, this ball is firstly at rest. Okay, when the boy is applying the force on this ball, the ball start moving, or the ball changes from the state of rest to state of motion. So by the force we can start a motion in any object which is at rest. Second effect of force we are having, a force may change the speed. If we are applying the force on the pedals of this bicycle, so the force can change the speed of the cycle. If you apply less force, less speed will be there. When you apply more and more force on the pedals, then cycle will be speed of the cycle will be more. Or a force can change direction also. For example, ball is coming towards this batman, and when this batman hits the ball, means applied the force, the ball changes its direction. Okay, so by the force we can change speed also. By the force, by applying the force, we can change direction of any motion of an object. Third effect of force we are having, a force may bring moving object in rest. If you want to this moving object should be at rest, then what you will do, we will catch the ball. So how we will catch the ball? When ball is coming toward this boy, this ball is in motion, but when this ball come toward this glove, so he will catch the ball. So in order to catch the ball, he is going to apply some force. So a moving object can come into the rest by applying the force. Next we are having, a force may deform an object. So by applying force, we can deform an object also. Deform means to change shape and size of an object. So by applying force, we are just changing the shape or size of an object. So next topic we are having, turning effect of force. So what do you mean by turning effect of force? When any object is fixed on some points. For example, we are having this door. This door is fixed at some points. This fixed point is nothing but pivot, or you can say pivoted point. Okay, so whenever you are applying the force on the handle of the door starts rotating about the fixed point, and this rotation of door about the fixed point is called turning effect of force. Okay, now let's see the definition. Definition is, a force may cause an object to turn about a pivot. Means whenever we are applying force to any object and that object start turning about the fixed point, that is known as turning effect of force. Turning effect of force is also called moment of force, and one more name is there, that is torque. Okay, turning effect of force first name, moment of force second name, then third name we are having torque of the same thing. Torque is also same thing, that when we are applying force to any object and that object start rotating about or start turning about a fixed point, that is also known as torque, and we are going to represent the torque by the symbol tau, this one symbol. Okay, so next we are having examples related to turning effect of force. Here we are having some examples, means in our daily life where we are going to use this kind of concept. So first we are having, when you apply force on the handle of door. Whenever we are applying force on the handle of door in order to open it or close it, the door always move about its fixed points or pivoted points. Okay, and when we are applying force and object start turning about the fixed point, that is nothing but a turning effect, moment of force, or you can say torque. Okay, next we are having second example related to this turning effect of force. When you apply force using foot on the pedal of bicycle, when we are applying the force on pedal of bicycle, pedal start turning or start rotating about the fixed pedal axis. So this applied force on the pedals and pedals start turning about the fixed axis is turning effect of a force. Third example we are having, when a key is put into a lock. When we are going to put the key into a lock and when we apply force on the key, this key start turning about the fixed point, and this applied force on an object and object start turning about the fixed point is known as turning effect of force. Next we are having next example. Next we are having factors affecting turning effect of force. So we have discussed that what is turning effect of force. Now turning effect of force is going to depend upon two factors. First we are having force. So how turning effect of force is going to depend upon force. When we are applying more and more force to any object that is pivoted at some point, that is fixed at some point, by applying more force, turning effect of force will also increase. So, greater the magnitude of force applied, when we are applying more and more force to any object, greater will be the turning object. So, in that object, greater will be the turning effect is seen. Okay. Next factor affecting we are having perpendicular distance of force from the point of pivot. if there is a maximum possible distance from the pivoted point and the point where we are going to apply force. For example, here we are having handle of door and here we are having pivoted point. So here you can see maximum perpendicular distance is there between the force and the turn and the pivoted point. Maximum perpendicular distance means greater turning effect will be there in the force by applying less force. Means if there is a maximum perpendicular distance, so by applying even though less force, there will be a greater turning effect in the door or in the object. So turning effect of force are going to depend upon two things. First, we are having force, greater will be the force, greater is the turning effect of force. Second, we are having perpendicular distance. Maximum is the perpendicular distance from the point of force to the pivoted point, greater will be the turning effect of force. So next, on combining these two factors, when we combine force and perpendicular distance, here we are having relation between torque, force and perpendicular distance. So this relation says that moment of force or turning effect of force or torque is equals to force multiply perpendicular distance. So this formula we are going to use in order to solve the numericals. Okay. Next, we are having definitions of clockwise and anti-clockwise movement. Actually, in the 8th class, we are having just definitions of clockwise and anti-clockwise movement. So we will see only definitions. Okay. So first, we are having clockwise movement. What do you mean by clockwise movement? When we apply force to any object and that object start rotating about clockwise movement and start rotating in a clockwise movement, that turning effect of force is a clockwise movement. Okay, means when any object is fixed on a pivoted point or fixed on any point, and when we apply the force on that object and the object start rotating clockwise, that is known as clockwise movement. In the opposite, we are having anti-clockwise movement. As a name suggests, anti-clockwise means when object is fixed to some point and when we apply the force to that object, and by applying force, object start rotating in an anti-clockwise movement. So that is known as anti-clockwise movement. Okay. Next, we are having units of moment of force. So by using the formula of moment of force, formula we have discussed now only, that moment of force is equals to force multiply perpendicular distance, we will see the units of moment of force. So here we are having SI unit. Firstly, we will see SI unit of force, then we will see SI unit of distance. As we know, SI unit of force is nothing but Newton and SI unit of distance is meter. So what is the SI unit of moment of force? SI unit of moment of force is Newton meter. If you talk about the CGS unit of force, then CGS unit of force is dyne and CGS unit of distance is centimeter. So CGS unit of moment of force is dyne centimeter. SI unit is Newton meter, CGS unit is dyne centimeter. Next, we are having relationship between SI unit and CGS unit of force. Many times in the exams, this question also came that what is the relationship between SI and CGS unit of force. So here we are having the relation. This you have to remember. So 1 Newton meter is equals to 10 raised power 7 dyne centimeter. As you know, 1 Newton meter is nothing but a SI unit and dyne centimeter is nothing but a CGS unit. So this is a relation between Newton meter and dyne centimeter. And if you talk about the definition of 1 Newton meter, that what is the definition of 1 Newton meter? So here we are having definition. 1 Newton meter, can you write it like this? 1 Newton multiply 1 meter. So 1 Newton meter means when you apply the force of or constant force of 1 Newton to that object which is at the perpendicular distance of 1 meter from the fixed point, that force applied, that turning effect in the force is 1 Newton meter. I will explain you again. 1 Newton meter means when you apply the constant force of 1 Newton to any object which is fixed at perpendicular distance of 1 meter, and that force or that turning effect in that object is a 1 Newton meter. Next, we are having numerical problems related to turning effect of force or moment of force. So first we have given numerical, a force of 2.5 Newton. As we can see, Newton is given. Newton means here we are given with force. First of all, write the given things. Whatever things are given in the numerical, just write it here. Okay. A force of 2.5 Newton. So force is given 2.5 Newton acts on an object at a normal distance of 40 centimeter. Distance is given. Centimeter means distance. So perpendicular distance is given 40 centimeter from the turning point. Calculate the moment of force. Moment of force or turning effect of force, or you can say torque, we have to calculate. As we know the formula, torque is equals to force multiply perpendicular distance. So torque is what? In order to calculate the moment of force, either this unit should be in SI unit, either force should be in meter and distance should be in centimeter, or you can use in the CGS system. Means force should be in dyne and distance should be in centimeter. So here you can check that it is easy to convert the, it is easy to solve the numericals in a SI unit system. So here in the force SI unit system already given, but distance is given in CGS. So can you convert the CGS unit system into SI? Means can we convert 40 centimeter into meter? Then yes, easily we can convert. As we know, in 1 centimeter, 1 by 100 meter is there. So just convert it. So it will be 440 divided by 100, that is 0.4 meter. So torque is equals to force. Force is what? 2.5 Newton. Multiply distance is what? 0.4. When you solve this 2.5 multiply 0.4, you will get torque is equals to 1 Newton meter. So here torque or moment of force is 1 Newton meter. Next we are having next numerical. The moment of force of 12 Newton. Newton is given, means here force is given. So force 12 Newton is given. About a pivot is 4.2 Newton meter. Newton meter is what? Torque is given. Okay, 4.2 Newton meter. What is a normal distance? So distance D we have to calculate. So as we know the formula, torque is equals to force multiply perpendicular distance. So here torque is given 4.2 is equals to force is given 12, but distance we have to calculate. So you can see 12 is in multiply, that side it will go in divide. So 4.2 divide 12 is equals to D. When you solve this, 4.2 divide 12, you will get 0.35 meter as a distance. Might be math calculation you are knowing how to solve. If you don't know, you can see here also. First of all, write 4.2 and this divide I am going to write like this, divide 12. Okay, 4.2 decimal I am going to convert into a fractional form. So it will be 42 by 10 divide 12. Then we are having 42 by 10 divide, we are going to convert into multiply. When you will convert divide into multiply, then the next term is going to reciprocal. So next term is going to reciprocal. Then just cut it. This way we are going to cut on 2 table. So it will be here 21, here it will be 6. Next we can cut on 3 table. It will be 2, it will be 7. So here we are having 7 divided by 2, 3.5 by 10. So when you will solve 3.5 by 10, by shifting the point, you will get 0.35. So distance is nothing but 0.35 meter. Next we are having some examples and applications of moment of force. Some examples and applications means where in our daily life we are going to see the moment of force, that we are going to discuss one by one. So first we are having a handle is fixed on a door at maximum possible distance from the hinge. Means from this hinge point or this pivoted point, this handle is fixed at the maximum possible distance. Might be now you can guess why this handle is fixed at maximum possible distance, because greater will be the perpendicular distance from the pivot and that of handle, and greater will be the turning effect of force. Means by applying even though less force, we can easily rotate the door about its fixed point. That is why handle is always fixed at the maximum possible distance. Next we are having, we prefer to use a spanner with long arm. We always use a spanner with a long arm. Why? Because here we are having fixed point. This is a pivoted point, and from here, from this point, we are going to apply the force. As you can see, from the point of application of force and the pivoted point, maximum possible distance is there. If greater perpendicular distance will be there, then greater turning effect will be there by applying even though less force. That is why always we are using the long arm spanners in order to rotate it easily by applying less force. Next we are having, a mechanic uses screwdriver of long and thick arm. Same with the screwdriver also, we are using the long and thick arm. Why? Because if there is a greater distance between the force applied and the pivoted point, greater perpendicular distance means greater turning effect will be there, and even though with less force, it will move easily. Next we are having the hand operated floor grinder used in village home is provided handle near its rim. What do you mean by rim? Rim is this rotational part. Means this is the rotational part, and at the end of this rotational part we are having this kind of like hand is given on the floor grinder. Why this? At the maximum possible distance this hand is given, so that from this fixed point, from this pivoted point, if maximum possible distance will be there, then more perpendicular distance means more turning effect will be there, and even though by applying less force it can rotate very easily. That is why it is given at the maximum possible distance near the rim. This end point is known as rim. Okay. Next we are having potter's wheel. In a potter wheel also, potter is having here the fixed point, and from here he is applying the force. Why? Because maximum greater distance will be there. Here greater distance will be there, perpendicular distance. Greater distance means more turning effect will be there. If more turning effect means he has to apply less force, and this pot can rotate very easily. Next we are having example of seesaw. As this central point fulcrum is a pivoted point, this central point is a pivoted point, and here we are having the force applied. Okay, so here also the maximum possible distance is there between the pivoted point and the application of force. Maximum possible distance means maximum perpendicular distance means more is a turning effect, and even though by applying less force, turning effect will be more. Next we are having the new concept, that is a pressure. So what do you mean by pressure? Normal force acting per unit area means whatever force is acting per unit this surface area, that is known as pressure. Means how much pressure is applied. Pressure is the force applied on any object per unit its area, that is known as pressure. Next we are having pressure and thrust. The total normal force exerted by an object on a given surface. For example, this surface I am having, and on this surface this object is there. When this object is applying full weight on this surface, then this full weight or the total weight is nothing but a thrust. Or you can say, when an object is perpendicular on any surface, when object is perpendicular on any surface, that time that force is a thrust. But if it is like this, it is like not perpendicular, or here also it is some at angle, that time if we are applying force on any surface, that is simple force. Means here it is a simple force. But if object is at perpendicular distance, or if object is giving full weight to that surface, that is known as thrust applied. Clear? This is the difference between force applied and thrust. Okay. So here we are having the formula related to the pressure. Pressure is equals to thrust over area. You can also use like this, pressure is equals to force over area. But if the force is perpendicular force, if full object is going to show the weight on that surface, then that force is a thrust. But if that yes at some angle force is there, that is a simple force. Okay. So you can use any formula, pressure is equals to force over area, or you can use pressure is equals to thrust over area. Okay. Next we are having SI unit of pressure. So as you can see the formula of pressure is equals to force over area. So by watching the SI unit of force and by seeing the SI unit of area, we will calculate the SI unit of pressure. So SI unit of force is what? SI unit of force is Newton. Over SI unit of area is meter square. When you will combine this, you will get Newton per meter square. If minus meter square will go upside, then power is going to become in negative. So SI unit of pressure is Newton per meter square. Okay, and this Newton per meter square you can also write it like this, Pascal. Why Pascal? Because pressure concept is discovered by a scientist called Pascal. That is why we are using this concept, or that is why we are just watching the SI unit of pressure as Pascal also. And 1 Pascal is equals to 1 Newton per meter square. Okay, 1 Pascal is nothing but a 1 Newton meter square only, because both are the SI unit of pressure. Next we are having numerical problem related to pressure. For first numerical, we are having a box of 250 Newton. So here we are given with force. Force is 250 Newton. Weight is placed on a table. This weight is placed on a table means this full weight is placed on a table means this you can also say as thrust. Okay. If the base area of the box is this meter square, area is given with 0.2 meter square, find the pressure exerted. So pressure exerted we have to calculate, means how much pressure this box is giving to the table, that pressure we have to calculate. As we know, formula of pressure is equals to force over area, and you can calculate the pressure either in SI unit or in CGS unit. As SI unit of pressure is Newton per meter square, so units are also given in Newton and meter square only, so no need to convert into any other units. Okay, so just put in the formula. Pressure is equals to force is given 250 over area is given 0.2 meter square. When you will solve 250 divide 0.2, what you will get? 1250 Newton per meter square, or you can write 1250 Pascal. Any unit you can write. Okay, so by just simply watching the formula, just putting the values, you can calculate the pressure exerted. Next numerical we are having, calculate the force. So here force we have to calculate, which exerts a pressure of 60 Pascal. So it is going to exert a pressure of 60 Pascal on an area of this. Area we are given with 5 meters square. So as we know the formula of pressure, pressure is equals to force over area. Pressure is given 60 Pascal. Force we have to calculate. Area is given 5 meters square. So as you can see, 5 is in divide. That side it will go in multiply. So 60 multiply 5 is equals to force. When you will multiply 60 with the 5, it will give you 300 Newton. So 300 Newton force is going to applied on the object or any area. Okay. Next we are having examples of pressure in our daily life, means where this concept of pressure we are going to apply in our daily life. So one by one we are going to study. First example we are having, knife, blades, axes, scissors, etc. have sharp cutting edge. Why we are using the knife or why we are using the scissor of sharp cutting edge? Why? Because here you can see of the sharp cutting edge, area is minimum, means area is less. As we know, pressure is nothing but force over area. If area is less, then pressure exerted on any object will be more, because here pressure and force are directly proportional and pressure and area are inversely proportional. Means when you will give more and more force to object, their pressure will be more. If you just increase the area of any object, their pressure applied will be reduced. This is inversely proportional, this is directly proportional. As you can see in a case of knife. In a case of knife, sharp cutting edge is there. Why sharp cutting edge is there? Because here area is less. If area is less, then pressure exert on any object will be more. Means we can easily cut an apple by using a sharp cutting edge of a sharp knife. That is why we are using these all thing of sharp cutting edge, that we can cut easily by using the sharp cutting edges. Okay. Next we are having similar example, drawing pins, nails, sewing needles, etc. have pointed edges. Why these all things are also having pointed edges? Pointed edges means here area is what? Area is more or less? Area more means like this, area less means like this. Okay, area is less, as we know pressure is equals to force over area. If area is less, then pressure exerted on any object will be more. So this drawing pins or any nails can go into the wall very easily by applying the force. Okay. Next we are having a school bags and shopping bags have broad straps. Why we are using the broad straps of school bag? Because here you can see area of the strap is what? Area of strap is more or less? More. Okay. Area of the school bag is strap of the school bag is more. If more area is there, then pressure is equals to force over area. If area is more, then pressure exerted on our shoulder is less. That is why we are using the broad straps of shopping bags and school bags. Next we are having the handles of suitcase is broad. The handle of suitcase is also given broad. Why? Broad means Broad means larger area. So as we know, pressure is equal to force over area. If this handle is broad, broad means larger area, and pressure exerted on our hand will be less. Okay. Next, we are having shoes and sandals having pointed heels. It is very uncomfortable to use this pointed heel edges. Why? Because pointed heel means here area is less. If area is less, then pressure is equal to force over area. Area is less means pressure exerted on the ground will be more. It is going to means exert more and more pressure into the ground, and it is very uncomfortable to wear these kind of sandals. Okay. Next, we are having army tanks are extremely heavy. As you can see, these army tanks are extremely heavy, but their wheels are made broad. Why wheels are made broad? Broad means more area is there. More area means less pressure they are going to exert on the ground, so that they cannot sink into the ground due to their weight. That is why they are given with broad wheels, so that area can increase and pressure can reduce into the surface. Next topic we are having liquid pressure. So as we can see, like solid, all things, all state of matter, either it is a solid, liquid or gas, all things are going to exert pressure. And when liquid is poured into any glass, that liquid is also going to exert pressure on the walls of container, and that pressure exerted by a liquid on the walls of container is called liquid pressure. So see the definition of liquid pressure. A liquid contained in a vessel exert thrust at all points. So whenever liquid is contained in any vessel, that liquid is also going to show or exert force to each and every point, but below the surface area. Below the free surface means this is a free surface of water. Means above this no water is there, below this only water is there. So below the free surface, each and every particle of the liquid is also exerting pressure on the walls of container, and this pressure exerted on the walls of container is known as liquid pressure. Next, we are having lateral pressure. Here you can see particles are like this. Particles in a liquid are less tightly packed, like this they are tightly packed. Okay. So this molecule is giving pressure to this is giving to this is giving to this, and this is at last giving to this. It is not like this means only the pressure is going to give on the base of the beaker only. No, these molecules are going to give the pressure on sideways also. Means these molecules are giving or exerting pressure or exerting force on the sideways also, and this sideways and this liquid, when giving the pressure on the sideways also, that pressure is known as lateral pressure. Liquids not only exert pressure on the bottom of container, liquid is not giving pressure on the bottom of container, but also exert pressure on the walls of container. But it is also exerting pressure on the walls of container, and this sideway pressure of a liquid is known as lateral pressure. Now we are having factors affecting liquid pressure. Means on which factors liquid pressure is going to depend. So first we are having liquid pressure depends upon density of the liquid. Density might be you knowing density is equals to mass per unit volume. Means in given volume how much matter particles are contained, that is known as its density. Means in a given volume how much particles are contained in any substance, that is known as its density. If density of any liquid is more, then liquid pressure is also more. Then liquid will also exert more pressure on that material. Okay. Here you can take the example of water and kerosene. Might be you are knowing that water is having more density as compared to kerosene. If water is having more density, here I am just going to do one activity. In this container water is there, in this container kerosene is there, and at the bottom I am going to just tie up a balloon with these both containers. Okay. This water is having more density as compared to kerosene. If this water is having more density, means these particles are giving more and more pressure. So by applying more and more pressure, this balloon will blow up more. But kerosene is having less density. Less density, it is going to give the less pressure to any container or any this balloon. If less pressure is there, then this balloon is going to blow up less. So more is the density, more is a liquid pressure, and less is a density, less is a liquid pressure. Okay. Next, we are having second factor affecting pressure at a point inside liquid increases with depth. When we are going to more and more down into the sea or into any container, for example, in this container, water is poured, and when I'm going at the base of the container, at this base, pressure exerted by liquid is at the maximum. Okay, here pressure is very much high, but at the upper point, pressure is very low. So when we are going deep and deep inside to any liquid, deep and deep inside at the below surface, pressure exerted by the liquid is very much high. It is going to increase with the depth. Next, we are having liquid pressure remains same in all direction at a given depth. For example, if this we are having container in which water is contained. If you talk about these 2 points A and B, at A and B, same amount of liquid pressure is exerted. Means at the same level, same liquid pressure is there. It is not like this at the A point more pressure is there, more liquid pressure is there, and at B less liquid is pressure is there. No. At same depth, same liquid pressure is there. Okay. Next, we are having a liquid seek its own level. Means whenever we are going to put the liquid into different vessels, means different vessels. For example, water I am going to pour into these vessels A, B, C, D, which is having different shape and size. But when you will pour the water, but here you can see pressure is same. At the below surface, pressure is same. When you will put the water from upside, this water will take the same level. In all beakers, irrespective of shape and size, this liquid will seek its own level. Why? Because at the base, density is same. Due to same density, it will seek the same level. Next, we are having liquid pressure at a point does not depend upon shape and size of container. This thing we are knowing that liquid pressure does not depend upon shape and size, even though it is also independent of surface area on which act. Means if I'm going to put the water into different shaped object or different area or different volume, it is not going to change its density. It is not going to change its pressure exerted. Pressure exerted, liquid pressure will be same of water if I'm putting on this vessel, if I'm putting in this vessel. Okay. Next, we are having consequences of liquid pressure. Means where the liquid pressure is going to show their effect. So first consequences we are having pressure exerted by water in sea or ocean increases with depth. As we know, whenever we are going deep and deep inside into the water, pressure exerted below the surface is very much high. Then deep down the sea water, pressure will be very high. But as we know, in our body, pressure is less. Means pressure is equals to atmospheric pressure that we can withstand very easily outside the seawater. But when we are going more and more deep inside the seawater, their pressure is going to very much high, but our body pressure is less. So due to this difference in the pressure, our body may burst due to this, or body may crush due to very much high pressure. That is why the sea divers have to wear a special kind of suit in order to withstand the pressure inside the sea. Okay. Next consequence of liquid pressure we are having, submarines are built of hard thick sheet of special steel alloy. Submarines which are going to move deep inside the seawater, these submarines are made up of hard thick sheet of special steel alloys. Why they are made up of special steel alloys? Because these submarines have to move deep inside the seawater, and as we know, deep inside the seawater liquid pressure is very much high. So to withstand with that much high liquid pressure, so that their body may not get burst in the liquid pressure, these kind of submarines are made up of hard thick sheet of special alloys. Next, we are having next consequence of liquid pressure. Fish which may live in a deep sea have high blood pressure. Fish which live in a deep sea, they are having high blood pressure. Why? Because fish have to move deep inside the seawater, and as we know, deep inside the seawater liquid pressure is very much high. So to withstand with that much high liquid pressure, their blood pressure is also high, because outside also high liquid pressure is there, because outside also in the sea high liquid pressure is there, and inside also in their blood high blood pressure is there. So their effect is going to cancel out. That is why they are not feeling that much high pressure inside the deep sea. But if you take the fish outside the seawater, external pressure suddenly reduces, because external pressure is not that much high as in the case of deep sea. So that is why external pressure on their body reduces. Due to this sudden decrease in the external pressure, their body may get burst. Okay. Next, we are having pressure in gases. Each and every state of matter, either it is solid, liquid, or gas, they are going to exert pressure when we are going to contain in the container. So, as we know, solid are also exerting pressure, liquids are also exerting pressure when contained in a container. In a similar way, gases particles are also going to exert pressure when they are going to contained in any container. So, pressure exerted by gases on the body. Each and every gaseous particles are going to exert pressure when they're going to come in contact with any body. Next, we are having atmospheric pressure. As we know, we are living in a blanket of air, and this blanket of air is known as atmosphere. So these air particles are also exerting pressure above us, and this pressure exerted by the air column above us is known as atmospheric pressure. Now our question is how to measure the atmospheric pressure, means how much atmospheric pressure is applying on us by the atmosphere. Might be you are not knowing that when we are standing in a simple standard atmospheric pressure, so the particles which are present in the air, particles are exerting pressure on our body. Okay, and do you know the particles which are exerting pressure on us, that pressure is exactly equal to the pressure exerted by one elephant which is sitting on your head. Same pressure here, these particles are also exerting same pressure on us, and the when elephant is sitting on your head, exact same amount of pressure is also here also. Okay, but why we are not feeling this much kind of pressure? Because the blood pressure is also there, because in our inside arteries, veins are there, so that blood is also exerting pressure on our body, and same amount of pressure is exerting outside also air particles on us. So net effect is going to cancel out each other. That is why we are not feeling that much kind of air pressure or air particles of air to us. Now, how to measure the atmospheric pressure? So, the instrument named barometer. With the barometer, we are going to measure the atmospheric pressure. Diagram of barometer is like this. In a barometer, we are using a mercury. So, how to use this barometer? See carefully. Actually, in a barometer, we are using two instruments. First, we are having this kind of in a tube, and second, we are having this trough or beaker, you can say. Firstly, what you have to do? You have to take one test tube. So in the test tube, you have to fill it with mercury. So this test tube, we are going to fill it with mercury. When you will fill all the test tube with mercury, then air particles which are present inside this test tube, the particles will come out. So inside no air particle is there. So you have to just put your thumb on it, and just by putting the thumb so that no air particles can move inside, put your thumb and take it and put inverted into the trough of mercury. Okay. When you will put inverted in a trough of mercury, then what will happen? See carefully. Actually, due to the weight of mercury, mercury will move downside. Mercury is going to move downside due to acceleration due to gravity and weight of mercury. And when mercury is going to move downside, here vacuum is going to create, because as we know here air particle is there in this inverter test tube, no air particle is there. Okay, so here vacuum is created, and but outside air particles are there, means outside atmospheric pressure is higher, but inside atmospheric pressure is less. So these atmospheric pressure will force the mercury to move upside. These atmospheric pressure particles, these higher pressure will force the mercury to move upside, because each and every substance move from higher pressure to the lower pressure. But from the upside, mercury weight will send the particles downside. Mercury weight will send the mercury downside so that it may move downside. And when level will come, one point one level will come when neither mercury will move upside, neither or mercury will move downside. Okay, so this level, this height attained is 76 centimeters. So at 76 centimeter, mercury is going to stop at one point. So if you want to convert this 76 centimeter into meter, then you can write it like this also, 0.76 meter. Okay, so height attained by mercury is this. Now in the next slide, I will tell you how to use it, how to find the standard atmospheric pressure with this gadget. Okay, so the standard atmospheric pressure we are going to find by using the formula, that is, here we are going to use the standard atmospheric pressure. Atmospheric pressure, in order to find, we are going to use the formula H rho G. This is also formula, if might be numericals will come to you, so the same formula you have to use. Atmospheric pressure or pressure exerted on the atmosphere is equals to H rho G, where H is the height attained by mercury. This height attained Rho is the density of mercury. What is the density of mercury? That value here we have to put. And g is the acceleration due to gravity. G value is always constant, 9.8 meter per second square. This we will see the density of mercury, then we will see the height attained. Now just put the values here. Formula of atmospheric pressure is h rho g. Height attained by mercury is 0.76 centimeter. Density of mercury is 13.6 into 10 to the power 3. Multiply acceleration due to gravity. Value of acceleration due to gravity is constant, 9.8 meter per second square. Just write the value here, 9.8 meter per second square. This value you have to remember. And density of mercury is constant, and this we have calculated. When you will solve all the digits, then you will get 1.013 into 10 to the power 5 Pascal. So standard atmospheric pressure is approximately 1 into 10 to the power 5 Pascal. This is the standard value of atmospheric pressure which we are going to use. Okay. Next, we are having variation of atmospheric pressure. So what do you mean by variation? Variation means how the atmospheric pressure is going to change from place to place. So first we are having atmospheric pressure is more at sea level. Sea level means when we are going deep inside the earth, when we are moving down and down towards the earth, down and down particles are coming very close to each other. Okay, when particles are coming close to each other means these particles are exerting more and more pressure, and due to exerting more and more pressure here deep at the sea level, atmospheric pressure is very much high. But as we are moving to higher and higher altitude, at higher altitude particles are going to expand. Due to expansion, particles are moving away from each other. Away means these particles are exerting very less pressure on our body, and very less pressure means here atmospheric pressure is less. Okay, so at sea level atmospheric pressure is more, and at the higher altitude atmospheric pressure is less. Next, we are having next variation in a calm weather during winter season. During winter season, as we know, during winter season particles are cool up. Due to cooling, the particles are come close to each other. So due to closing particles, when particles are very close to each other means they are going to exert more and more pressure on our body. So in a winter season atmospheric pressure is high. But during the stormy summer season means particles are away from each other. Due to heat, particles expand up and particles move away from each other. Due to expansion in the air particles, these particles will put less pressure on our body, and due to less pressure, atmospheric pressure during stormy summer day is very much less as compared to winter days. Okay. Next topic, we are going to see effects of atmospheric pressure. Now we are going to study that what are the effects of atmospheric pressure in our daily life. So first we are having liquid rises in syringe when piston is pulled up. So in this kind of injection, when we are having the bottle of medicine, this medicine will move from this bottle into the syringe when piston is moved backward. So why this medicine move? For example, here piston is in this position. When piston is in this position means all the air particles are trapped in this position. Okay, particles are trapped means particles are very close to each other. When particles are very close to each other means they are exerting more and more pressure. So when piston is in this point, here pressure inside the syringe is high. But when we will move the piston, when piston is going to move backside, whatever the particles are trapped here, that all particles will take up the space and all particles will move away from each other. When particles move away from each other means they will exert less pressure. Now in this case the pressure inside the syringe is very much less, but as you can see outside, the pressure outside the syringe, here also outside and inside the bottle also, pressure is high. And as we know, liquid or any substance will always move from higher pressure to that of lower pressure. So in the same way, whatever liquid is present inside this bottle, that liquid will move from higher pressure to that of lower pressure. That is why liquid always rises in a syringe when piston is pulled backside. Okay. Next effect of atmospheric pressure we are having, ink get filled in a fountain pen. As we have studied that liquid can easily filled into a syringe by using the atmospheric pressure with the help of atmospheric pressure. In the similar manner, ink can also get filled in a fountain pen. So here what we are going to do in order to fill the ink into a fountain pen, we will take the pen with the nib here and we will put inside into a ink. Okay, we will put inside in the ink. Actually here in a pen one rubber is there. Here one rubber is there, and when you press the rubber, by keeping the inside in the ink only. When you press the rubber, whatever the air particles present inside the pen, that air particles will come out from the nib. Okay, and when you will release this rubber by pressing, after that when you release the rubber, by releasing the rubber means whatever the air particles inside present, that came out. Okay, and it creates a region of low pressure, and when it creates a low pressure here outside in a ink, it is having a region of higher pressure. And as we know, liquid always move from region of higher pressure to that of lower pressure. So this ink also move from higher pressure to that of lower pressure, means from this ink to the fountain pen. So that is why we can easily fill the fountain pen with the ink. Next, we are having rubber suction pads. Might be this kind of rubber suction pad you have seen in your daily life. Rubber suction pad, what they are doing, when you just take the rubber suction pad and put on the wall by just taking some force, and we will put on the wall, what it will do, it will send all the air particles, it will send all the air particle from the wall outside. When it will send all the air particles from from this wall, then means it creates a region of low pressure. But from outside atmospheric pressure is there, means region of high pressure is there. So outside high pressure will will force this rubber suction pad to stick on the wall. That is why this rubber suction pad can easily stick on a wall. Next, we are having lasers are able to adhere to the wall. Lizards are also able to move on a wall. Why they're able to move on a wall? Actually, these lizards are also doing the same principle as that of rubber suction pad. Here, these feet are also acting like a rubber suction pad. What they are doing when they're pressing their feet on a wall? Pressing the feet on a wall means they are sending all the particles what are present on the wall outside. Okay, they are sending all the particles of air particles outside, means lizards are creating a low pressure here, region of low pressure. And from outside atmospheric pressure is there, means outside high pressure is there. So this high pressure will allow to move the lizard properly on a wall, means it can stick to the wall easily. Okay, next we are having fifth effect, we are able to suck a cold drink. So we can easily suck a cold drink with the help of straw. So how we are able to suck a cold drink with a straw? See carefully. Actually, whatever air is present in our mouth, that air firstly we will move inside to our lungs. Means with the help of lungs we will take all the air particles, and that air particles move away from our mouth. Means in our mouth region of low pressure is there. Then afterwards we start sucking. Means whatever air particles are present inside this straw also, that air particles will also move to our mouth, and that air particles will also move to lungs. Means here in mouth also, here in straw also, both of the conditions we are having region of low pressure. But in this cold drink or this lime water, we are having the region of high pressure, because here pressure is more. So as we know, liquid always move from region of higher pressure to region of lower pressure. So this liquid start moving from higher pressure to lower pressure into our mouth easily with the help of straw. Next effect of atmospheric pressure we are having, astronaut wear a specially designed suit. So astronauts always wear a specially designed suit when they have to move in a space. Why? Because as we moving to higher altitudes, at the higher altitudes atmospheric pressure is less, but our blood is exerting same pressure on our body. So to withstand with that change in that pressure outside and inside the body, they are wearing specially designed suit so that their body may not crush when they are moving outside, when they are moving to the higher altitudes. Next, we are having atmospheric pressure decreases with increase in altitude. As we know, whenever we are moving to higher and higher altitudes, their atmospheric pressure reduces. When atmospheric pressure reduces, see carefully, actually our blood is producing pressure or exerting pressure on our body. When outside pressure reduces, here it is a region of low pressure, but inside the body there is a region of high pressure. And as we know, liquids always move from region of higher pressure to region of lower pressure. So blood start coming from our body, and we are having one opening on our mouth, that is nose. So blood start moving from the nose towards the outside. Means whenever we are moving to higher altitude, their atmospheric pressure is less. Due to this less atmospheric pressure, the blood start coming out from the nose to the person due to change in the atmospheric pressure. So this is all about your chapter number 3, that is force and pressure of class 8th ICSE. If you like the video, please like it, share it and subscribe our YouTube channel. Thank you so much.